All right, so we have a couple of problems that I want to look at here where the instructions are going to say to evaluate the indefinite integral. Okay, so there's this word indefinite integral. If there's an indefinite integral, then there's probably at some point going to be a definite integral. And in fact, that's the case. So for now, what we're going to do is we're going to take a look at this problem I have written on the left-hand side. What we want to know when we see this symbol, we want to be able to answer this question. What did I take the derivative of? What did I take the derivative of? I'm going to abbreviate that to get negative x to the fifth. Okay? Well, if you remember, when we take a derivative, we bring the exponent down and subtract by 1, okay? So to undo the derivative, instead of subtracting the exponent by 1, we're going to add 1 to the exponent. Now, we mentioned how when we're taking the derivative, we bring the exponent down and we multiply these values. So to undo a derivative, we're going to take whatever that exponent is and divide by that thing, okay? So this is that basic antiderivative rule for x to the n. So in our case, with this first problem, n is going to equal 5. So to find this antiderivative, what we would do is we would take our original problem and we can break it up into negative x to the fifth dx. We'll explain the importance of dx a little bit later. Plus the antiderivative of 6e to the negative 2x dx. Okay, so as we said here, n is equal to 5, so we're going to add 1 to that. So 5 plus 1 over 5 plus 1. Don't forget to keep up with the negative here. The antiderivative for what we have here is a little more involved, okay? So when we take the antiderivative of this thing here, it's going to be 1 over b e to the bx. Okay, so in our case, b is equal to negative 2. So that begs the question, well, what do we do with this 6 right here? Okay, well, 6 is a constant, and one of the properties of this antiderivative is that we can take that 6 and simply move it to the outside. So if I do that here, then I'm going to have plus 6, and then the antiderivative of what's right here. We said 1 over b, 1 over negative 2, e to the negative 2x. Okay? And then you're probably seeing this random plus c that shows up, and I'll go over that in just a second, okay? So let's simplify this to make sure that we're on the right track. We're going to have negative 1/6 x to the 6th, okay? 5 plus 1 is 6. This 6 and negative 2 will cancel to give me a negative 3, e to the negative 2x plus c. So this c stands for an arbitrary constant, okay? So in other words, some random number, okay? And the reason for that is, if I take the derivative of this term, I should get negative x to the fifth. And if I take the derivative of this term, I should get 6 e to the negative 2x. Well, what is the derivative of any constant? Well, the derivative of any constant is 0. And so we don't really know what that number is that's sitting out here. We just know that it could be 5 or pi or e or 1 over 7, or there could just be no constant there at all. Because we don't know, right, we refer to this thing as an indefinite integral because we don't know for sure what that value of c is, okay? Let's take a look at another example right here. And this one is written a little more intimidating when you look at this guy. Well, what we're going to do is we're going to take this and use some of these things that we've done before in math classes where we can break that fraction up into 2 pieces like so. Okay. Well, I can simplify. You know that when I divide, I subtract exponents. So I have this antiderivative, and I have this antiderivative. So two things that I'm going to be looking for here, trying to find the antiderivative of each of those. Well, again, we can go back to what we know here. N is equal to 4, so I know that the antiderivative of this first one is going to be 4 plus 1 over 4 plus 1. And as we said earlier, this 5, it's a constant. So I'm going to move all that 5. I'm going to take all of it and move it outside that integral. And if I do that, I'm left with 1 over x. Okay, so here we're going to have minus 5, and then the antiderivative of 1 over x dx. Well, that's going to be one of those properties, one of those that you may have seen in a chart somewhere along the way. Antiderivative of that is ln x. And then we have our plus c. Okay? We could simplify this, obviously, to x to the 5th over 5 minus 5 ln x plus c, but that's really kind of how I do that. So if you're struggling, if you didn't get that chart of antiderivatives, let me know. I'll be glad to send that to you. But this maybe could give you a little bit of a hint of how to attack the homework here. And if you need additional help, you can always reach out.